So I'm going to assume you've read number 8 and you have some idea of at least what it's talking about here. I'm not going to do all of the parts in detail because I feel like a little bit of this I did yesterday, but I am going to address everything here to some degree. So the first thing I'm going to do, not in detail, is part A. That's because I definitely did a speed calculation yesterday with you. So I said if we're parametric, or if you notice, vector, this is how we're going to find speed. So that's how you take the absolute value of a vector, or the magnitude of a vector, or find the speed parametrically. The only thing I'm missing is dx dt. We don't know that one, but we know x. So that then is the formula. And you evaluate this formula at t equals 1, and it gives you the value that you are looking for. Okay. Part B, I'm also not going to go in much depth on because I also did this yesterday, and the only problem I did with you. So that exists. I'm going to integrate from 0 to 4 the speed, because that's how you get total distance. Now I know you have an answer key, and I know the answer key has a correct answer on there. However, I still think it is worth your time to practice on both of these, typing into the graphing calculator. Make sure you do these repetitions because you're going to want a little bit of experience before we go after this in a more challenging fashion. Okay. Part C. Find the time t on the interval 0, 4 when the line tangent to the path of the particle is horizontal. Is the direction of the motion of the particle toward the left or toward the right at that time? Give a reason for your answer. I hope you would all agree with that statement. We're talking about being a horizontal tangent. Then we're talking about the first derivative equal to 0. Now, this is one of the complex, well, not complex, but definitely confusing things that we should make sure we have clear in our heads when we are working with parametrics and vectors and polar. What is meant by first derivative? Dx dt is only the first derivative of the x, of the horizontal. Similarly, dy dt is only for y, the vertical. When we're talking about the first derivative being equal to 0, what we're talking about is the curve. So you want to be very careful with your reasoning when it comes to parametrics and vector and polar. A lot of it is going to feel the same. I hope a lot of it has felt the same so far. This is one of those differences. Another one of the big differences, the speed calculation. Another one of the big differences, just slipped my mind. Hopefully it will come back to me soon. But the first derivative of the curve, because the curve represents the graph. So be really, really cautious when you start throwing around derivatives. Make sure you're being very careful. Make sure you're being very clear. Make sure you are thinking carefully to yourself. Oh, I just remembered the other thing that's very different. Calculating the second derivative is very different too. Anyway, I don't need to do that. What I need to do here is determine what dy dx is. Fortunately, I remembered, just like you should remember, dy dx in the parametric fashion is dy dt divided by dx dt. Now I'm going to show you something that's not part of the problem, but may help you understand a little bit of what's going on here. Imagine for a moment, we decided to write this as, instead of dy dt divided by dx dt, multiplication by the reciprocal. So if we have dy dt divided by dx dt, we could instead say dy dt times dt dx, and look what happens. The dt's are common factors in the numerator and denominator, so you get dy dx after all. So that's not really part of the problem. That's just math I feel like I should mention. Anyway, dy dx. Oh, I wrote this wrong. That says dy dt. I meant to write dy dx. That is a mistake. Okay, dy dt we already know. Dx dt we figured out. So we figured out dx dt in part A. That was 2t minus 4. dy dt was given to us. That's te to the t minus 3 power minus 1. That's a yucky one. So you set this equal to 0. Yeah, that's what you set equal to 0. And then we're going to solve. T cannot equal 2 because then this would be undefined. So you're solving this equation, te to the power of t minus 3 minus 1. You're solving that. How are you going to solve that? Answer, calculator. Don't finagle around. Don't fool with the algebra. If you have a calculator, which I've already said you have a calculator for this question, you go right into it. Treat the t like x. I don't need to go parametric. So x e to the power, I think it was t minus 3 minus 1 looks like there's only 1 0 on there. So I find that in the normal fashion. That's too far, but no one cares. Right? Nobody cares. 2.208. But remember, we should be in the habit of storing things. 2.208. Why am I storing that? I believe that's because I have not answered the question yet. All I've determined is the value of t on the interval 0, 4 where this happens. Is the direction of the particle toward the left or the right at this time? Since dx dt, it's got to be greater than 0, right? Because if t equals 2, this is 0. If t is bigger than 0, that's going to be bigger than 4. Particle is moving to the right. Bang. Just like that. Shall I do part D? Or do we want to practice? Let me pause here while we mull that over. Part D it is. Part D says, there is a point with x coordinate 5 through which the particle passes twice. Find each of the following. I, the two values of t when that occurs. Okay, so if the x value is 5, it would be fair to say that this is true, right? That'd be fair to say. Okay. Oh, I forgot the constant. +8. Now, I have not reminded you of this in a while. I'm going to remind you of this. Do not write this. This is a quadratic equation. When you have a quadratic equation, you don't want things on different sides. You want everybody on the same side. I believe I have done that correctly. Similarly, I believe that this factors. That is part I taken care of. Those are the two times where the particle has an x value of 5. Part double I, the slopes of the lines tangent to the particle's path at that point. Okay. So the English there is a little bit difficult to parse. But what we need to do is evaluate the slope, which again is dy dx. It's not dx dt, it's not dy dt. You could say that's the slope of the horizontal and the slope of the vertical, but we want the slope of the curve. So I want to evaluate dy dx at t equals 1 and evaluate dy dx at t equals 3. And I can use the same dy dx that we used earlier, say back in part C. I'm not going to do that. Sorry. The y coordinate of that point given y of 2 equals 3 plus 1 divided by e. How are we going to do that? That's probably what you're wondering. How do you do something like that? So remember, x of t is 5. We would like to know the y value when x of t is 5. How can we make that happen? Because this one here is when t equals 2, right? That's not what we want. Because we have 1 and 3 for that. So we can't just do that. So Another thing I'll point out, we can find an antiderivative of dy dt. But this is a calculator question. So even though we can do that with parts, that can be done with parts, we're not going to do it with parts. We're going to use our calculator if we're going to find an antiderivative. And we're actually going to find an antiderivative. So let me, as we are getting short on time, suggest to you that there are two ways this can be done. So here's something we can think about. We can think about these equations. So let's make sure we understand what these equations represent. So this thing here, this would be displacement y direction only. From 1 to 2. This one is the same thing as that one, but for we're going from 2 to 3. Think about the notation. Think about how this is the change in y. We're integrating the change in y from 2 to 3. The change in y, the derivative of y, the velocity of y, the change from 2 to 3. That's this. This is the same thing, but from 1 to 2. So you may be wondering, why did I select 1 to 2 and 2 to 3? Why didn't I say choose something else? Well, the reason why I didn't say choose something else is because what I'm interested in is right here. This is what I'm interested in. I'm interested in y at 1, which is the same thing as y at 3. That's what the question is asking for. It says, what is the y coordinate given that y at 2 is 3 plus 1 divided by e? That is the other reason why I used 2 in both cases, because I know this. I already know that this is the case. So I have an equation I can solve. I can do this integral, either the blue one or the green one, on my calculator. And then I have y of 2. So I have an equation that has 3 unknowns, but there's not actually 3 unknowns. There's actually 1. One of them I get on my calculator, that's this integral. One of them is given to me in the problem, that's y of 2. And the third one is the thing that I'm solving for. So I'm going to arbitrarily decide that I will do the first one, but you can do the second one and get the same. So I want to integrate from 1 to 2. I typed that into y sub 1, I'm pretty sure. If not, I will fix it for you. Okay, so I got that. I'm going to store that just in case I need it. So 0.632 with a negative on it. So I'm gonna subtract 3, and I'm gonna write some terrible algebra in here. It's gonna give you nightmares, but it's fine. That's gonna give me the same thing as y3. So I will not simplify that for you. I will leave that for you to enjoy sometime on your own.